Good morning, everyone. Welcome to the basic electronics class. Today, we will discuss a very important concept of operational amplifier, that is, the applications of op amp, or you can call it as operational amplifier applications. So, there are different applications we are having for the op amp. In this topic, we are going to discuss some of the application where all this operational amplifier can be used. So this operational amplifier can be used as inverting amplifier, it can be used as non-inverting amplifier, voltage follower, summing amplifier, or else you can call this as a summer, addition of two voltage signals. The fifth application is difference amplifier, or else you can call it as subtractor, integrator, and differentiator. Since this amplifier performs all the mathematical operations such as inverter, voltage follower, summer, subtractor, integrator, and differentiator. Because of this reason, this is called as operational amplifier. So in this lecture, we are going to discuss about the inverting amplifier, that is how operational amplifier can be used as inverting amplifier. So let us start with the inverting amplifier. So this is the circuit diagram of inverting amplifier, how the operational amplifier can be used as inverting amplifier, that is given in this circuit. In this circuit, it consists of operational amplifier with two input terminal. One is negative terminal, that is also called as inverting terminal of operational amplifier. Another one is non-inverting terminal, or else you can say that positive terminal of the operational amplifier. So since the input voltage Vin is connected to the inverting terminal or negative terminal of the op amp, so it is called as inverting amplifier. And non-inverting amplifier, that is positive terminal of the operational amplifier, that is connected to the ground. You can see the circuit diagram here. The inverting terminal is connected to the input voltage Vin through resistance R1, and non-inverting terminal is directly connected to the ground. So the voltage at non-inverting terminal is 0. And one more resistance, that is resistance RF, is connected between output and input. So that is the part of the output, that is output voltage V out, is connected back to the inverting terminal through resistance RF. This is called as negative feedback, or else you can call it as a feedback network. So in this feedback network, we are having resistance RF. With this, we can say that if we apply the input voltage Vin as sine wave, then the inverting amplifier using this operational amplifier, so it is going to give output as inverted output. So if you compare the input and output, there is a 180-degree phase shift between input and output, or else you can say that, so there is exactly inverted output we are going to get with respect to input. So this is the definition of your inverting amplifier. So how we are going to define the inverting amplifier now? The first thing is that the input voltage Vin is connected to the inverting or negative terminal of the operational amplifier as shown in circuit diagram, and also the phase difference between input and output is 180-degree apart. So because of these two reasons, we are calling this configuration as, this op amp configuration as inverting amplifier. Let us see now the voltage gain of inverting amplifier, that is how we are going to derive the voltage gain of inverting amplifier. This voltage gain is denoted as AV. Now let us see one by one. So before going to the expression of voltage gain, we must also know that what is this voltage gain, how we are going to define the voltage gain of any device. So here in this circuit, or in general, we can define the voltage gain as output voltage divided by input voltage. That is, the ratio of output voltage to input voltage is defined as voltage gain. This definition you must remember for the derivation of this voltage gain. Then how we are going to derive the voltage gain for inverting amplifier? Let us see a step by step derivation. First, what we have to see that, so we need to know what is the current flowing through resistance R1. What is the current flowing through resistance R1? We must know. So that current which is flowing through resistance R1 will be moving towards the point V2. V2 is nothing but voltage at that inverting terminal, and we know that the input impedance of op amp is very high. It is ideally it is infinity. What is input impedance? Input impedance is nothing but resistance offered at the input terminal of the op amp, and that input impedance is very high. It is ideally considered as infinity. Because of this infinite input impedance, the current which is flowing from the Vin will not go into the operational amplifier. Now, how we are going to define then? How we are going to calculate the current flowing through resistance R1 then? So, according to Ohm law, the current will be calculated as I equals to V divided by R. We know that. So, in case of this, we have two voltages at two end terminal of your resistance R1. One is V in, another one is V2 at that inverting terminal. Then difference between these two voltages is nothing but voltage drop across resistance R1. Then what is the voltage drop across resistance R1? V in minus V2. Then we know the value of resistance R1. So if you want to calculate the current flowing through resistance R1, then it will be I equals to, the current I equals to V in minus V2 divided by resistance R1. So you can ask me why we have taken V in minus V2. Always whenever you want to calculate the voltage drop across resistance, you can consider two end voltages, that is potential difference between two end terminal of the resistance. Now in case of this two end voltages, that is potential difference between end terminal of the resistance R1 is V in and V2. So then the difference between these two will become a voltage drop across resistance R1. So because of this, I have written an equation here, that is I equals to V in minus V2 divided by resistance R1. This equation we will take it as a equation number 1. Similarly, we need to calculate what is a current flowing through resistance RF. RF is nothing but, as I have told you, it is a feedback resistance. Now, what is the current flowing through this resistance RF? Now again we need to consider the voltage drop across resistance RF divided by the resistance RF will give you the current flowing through resistance RF. Then how to calculate the voltage drop across resistance RF? In the similar steps what we have calculated in equation 1. So that is, again we need to consider potential difference between two end terminal of the resistance RF. Then which are the two end terminals we are having for resistance RF? One is V2, another one is V out. Then the difference between this V2 minus V out divided by resistance RF will give you the current flowing through resistance RF. Then this will be considered as equation number 2. Now if you compare the equation number 1 and 2, the LHS side of equation 1 and 2 are same. Why? Because the same current is flowing through resistance R1 and as well as resistance RF. Why? Because the input impedance of your operational amplifier is very high, so then no current will be flowing through input terminal of your op amp. Then all the current which is generated by the input voltage will be transferred through resistance RF. Then with this reason we can equate equation number 1 and 2. So then we are going to get the equation as I equals to V in minus V2 divided by resistance R1, that is equals to V2 minus V out divided by resistance RF, and this equation we are going to consider it as a equation number 3. Now we need to see one important concept here, that is called as virtual ground concept. What is this virtual ground concept? So now in the circuit diagram, if you see, the positive terminal of the op amp, that is non-inverting terminal of the op amp, is connected to ground. Then virtually the same voltage will be there at the inverting terminal also. Why? You can ask me why. Since we have high input impedance, the resistance at the input terminal between negative and positive terminal is very high. It is almost infinity. Then there is no current flow through the input impedance, that is input terminal. Then if there is no current flows through input terminal of the op amp, then the voltage drop across that input terminal will be 0. Then whatever the voltage you are having at the non-inverting terminal must be equals to the voltage at the inverting terminal. So the now non-inverting terminal is connected to 0, and the V2, the voltage at inverting terminal, that is V2, that is also considered as 0. It is also considered as 0. Then according to virtual ground concept, V2 is 0. V2 equals to 0. Then if you substitute the value of V2 as 0 in equation number 3, then equation 3 becomes I equals to V in minus 0 divided by R1 will give you V in divided by resistance R1, and that is equals to V2. V2 is 0, that is 0 minus V out divided by RF will give you minus V out divided by resistance RF, which will be considered as equation number 4. Then this equation number 4, if you simplify, so in terms of V out divided by V in, V out is nothing but output voltage divided by input voltage. Now we have defined what is voltage gain. Voltage gain is the ratio of output voltage to the input voltage. If you simplify such that the output voltage equals to input voltage, that is nothing but AV. AV is voltage gain. Then we are going to get the equation as minus RF divided by R1. So where RF is feedback resistance, R1 is the input resistance, minus sign indicates that there is a 180 degree phase shift between input and output. What is that 180 degree phase shift? So that is output you are going to get exactly inverted with respect to input. So that is indicated with the help of negative sign in the equation. So the voltage gain of inverting amplifier is AV equals to minus RF divided by R1. With the help of this equation, you can calculate so what will be the value of voltage gain of your inverting amplifier. So in next video we will see what is non-inverting, how the op amp will be used as non-inverting amplifier. Hope this inverting amplifier is clear for all of you. Thank you.